Hello everybody and welcome to AlgoExpert. In this video, I'll be covering the question of class photos. Now before we dive in, let's make sure we understand what the question's asking of us and the input and output structure. So for this problem, we're going to be given two input arrays. The first input array will represent the heights of students that are wearing red shirts, and the second input array will represent the heights of students that are wearing blue shirts. Now these arrays will always be the same length, they will have the same number of elements, and what that really means is that there's always going to be the same number of students that are wearing red shirts as there is that are wearing blue shirts. Now we can assume that all of the heights of our students are going to be positive, non-zero integers, and these heights are not necessarily going to be unique. So we could have students that have the exact same height. Now what we're being asked to do is determine if we can take a photo of these students that adheres to the following constraints. Now those constraints are as follows. All of the students that are wearing red shirts must be in the same row. All of the students that are wearing blue shirts must be in the same row. Our photo must have exactly 2 rows, and these 2 rows must have the same number of students in them. Also, every student that is in the front row must be strictly shorter than all students that are in the back row. So for example, let's say we were to have 2 students, one student of height 7, another student of height 6, then the student of height 7 would need to be in the back row because they are taller than the student of height 6, and that student would have to be in the front row. So hopefully you understand, but that is what this problem is asking us to do. We are asked to return true if we are able to take a photo that follows those constraints. Otherwise, we are asked to return false. So for this sample input, the result is true. Now let's quickly go through it and understand how we can arrange the students in our photo such that we have a photo that follows these constraints. So I've just moved both of my arrays upward so I have a little bit more room on my screen, but now I'm going to draw the 2 rows of students. So the first thing to realize here is that since all of our students with red shirts need to be in the same row, and since all of our students with blue shirts need to be in the same row, whatever our tallest student is, or specifically whatever color shirt our tallest student is wearing, that is going to mean that that color shirt must be in the back row. So for example, in this sample input, we see that our tallest height is 9. Now what that tells us immediately is that blue shirts must be in the back row. Because if we were to have red shirts in the back row, then there would be no way to find a student that we could place behind a student of height 9 that is taller than it. Because remember, all of the students in the front row must be strictly shorter than all of the students that are in the back row that are directly behind them. So you'll see what I mean in 1 second. But the way that we could arrange the students is as follows. So firstly, our blue shirts need to be in the back row. So I will start by just arranging my students where I have the student with the tallest height that is placed first. So I will have my first student right here. This is going to be wearing a blue shirt. So I'll just write a B there. And this has height 9. So B9, blue shirt, height of 9. Now, the student that I'm going to place in front of this student is going to have a red shirt. And I'm just going to pick the student with height 8 to place there. So it'll be slightly shorter. This is going to have a red shirt and height 8. Now I will place my next student in the back row. So we've done 9 and we've done 8. So now I will place my student with height 6. So height 6 will be slightly shorter, wearing a blue shirt, height 6. And then I will place my student with height 5 in front of them. So height 5 like that. We'll say red, and then we will say 5. Now we will place our next student in the back row. So that's going to be a student with height 5. So this will be blue shirt and a height of 5. We then will place our next student in the front row, so red shirt with a height of 4. And I am trying to draw this slightly to scale with the student's height, but obviously it is fairly hard to do that. So now I'm going to have a red shirt with height 4. Next, I'm going to place my student with height 4 that has a blue shirt. So we'll place this guy right here, blue and height of 4. Then I will place my student with height 3 in front of him. So like that. Red and height of 3. And then lastly, I'll place my student with height 2 and my student with height 1. So student with height 2 will be right there, blue shirt, height 2, and then student with height 1 will be there, red shirt and height 1. So this is an arrangement of students that is indeed valid, which means that we can take this class photo that follows those constraints. Because all of our students with blue shirts are in the same row, all of our students with red shirts are in the same row, and if you look directly in front of all of the students in the back row, all of these students are shorter than the students in our back row. So if you are able to arrange your students in a way somewhat like this, where those constraints are satisfied, then you are able to take the photo and you return true. If that is not possible, then you return false. So now that we understand this problem, let's talk about how we can solve it. So if you were paying close attention to what I just did, that example that I just ran through, then you may actually already know the solution to this problem, because I actually went through exactly what I'm going to show you right now. As I just did, the very first step in our algorithm, or the very first step to solve this problem, is going to be to determine which color shirt should be in the front row and which color shirt should be in the back row. Now, as I told you just a few minutes ago, the way we're going to determine which color shirt is in the front row or the back row is by looking at our tallest student. Whatever color shirt our tallest student has, well, that's the color shirt that's going to need to be in the back row. Because again, if my tallest student is, say, height 9, there's going to be no way to place this student in the front row and have the photo that follows those constraints, because there will be no student from the red shirts that we could place behind it that's going to be taller than this student. So that is the first thing that we need to do, pick whether red shirts or blue shirts is going to be the front or back row. So once we've determined that, then what we need to do is figure out if we're able to place students in the row properly. Now, once we've done that, we figured out which row red shirts and blue shirts are going to be in, we need to place our tallest students, specifically the tallest student that's wearing a blue shirt and the tallest student that's wearing a red shirt. We want to place these tallest students and figure out where they're going to be. So we determined that blue shirts has the tallest student of 9 and red shirts has the tallest student of 8. So what we do now is we place our blue shirt student with height 9 at the back, and then we place our red shirt student with height 8 directly in front of it. Now, the reason we do that is because this student here, the student with height 8, is going to be the hardest to place. The reason this student is going to be the hardest to place is because it is the tallest. So it's going to be the most difficult to find a student that is taller than this and place it behind this student. Because if we know that red shirts is in the front row, then we know that we need to find a student that is taller than the tallest student in our red shirt to be placed behind it. So this is kind of the idea behind this solution here. We need to realize that placing the tallest student in the front row is the hardest thing to do. So we do that first. And if that is possible, then what we can say is, all right, we have finished placing the tallest student. So now we can imagine that this problem is actually identical, except we've removed these two tallest students. And we already know the order for our red shirts and blue shirts in terms of what row they're going to be in. So now that we've placed the tallest student, we need to place the second tallest student, because the second tallest student is going to be the second hardest student to place. So we find the tallest student in our red shirts, which is 5. And then we find the tallest student in our blue shirts remaining, the ones that we haven't already placed. And we say, okay, well, is the student that's in our blue shirts taller than the student that's in the red shirts? Or specifically, is the next tallest student in our blue shirts taller than the next tallest student in our red shirts? Now, in this case, it is, which means we can make an accurate placement. So we place our student with height 6 and then our student with height 5. So now I'll cross these off. And now again, the problem is the exact same, except now we've placed the two tallest students. So now we move on to the third tallest student, because again, that's going to be the hardest one to place. So we see that we have a height of 4. So we then look in our blue shirts array and we find the next tallest student that we've yet to place. In this case is 5. Now, since this student is taller than the student in the red shirt, we're able to make this placement. So we do that, we place 5 and then we place 4. Now, I think you get the idea, but that's all we need to do to solve this problem. We need to simply sort the red shirts and the blue shirts. We then need to loop from the tallest student to the shortest student, and we need to compare at every single step if the student that is the tallest that is placed in the front row is shorter than the student that is the tallest that is going to be placed in the back row. Then we eliminate those two students because they've already been placed, and we continue on until eventually we find that we cannot take the photo, or we get through all of the students, we're able to place them, and then we can take the photo. So let me just show you a quick example of what would happen if I were to change these input arrays slightly. So let me erase these two numbers right here, and I will rewrite 5 and 8. But now what I'm going to do is change this to be 9, and actually let's add another value here, which is going to be 5. So now if we have 9, 5, 2, 4, 5, and then up here 5, 8, 1, 3, 5, let's see if we're able to make a photo that follows the constraints. So if we place our tallest student from both of these lists here, both of these arrays, we have 9 and 8. So let's place that 9 and 8. Now we're going to place our second tallest student. So our second tallest student in the blue shirts is 5, and our second tallest student in the red shirts is 5 as well. So we place 5 and we place 5. But now we see that we actually cannot do this because the student that is in the front row, the student that's wearing the red shirt, is not shorter than the student that is in the back row. So what that tells us is there's actually no way to take this photo, and we just go ahead and we return false. Because if the second tallest student in our red shirts is 5, and there's no student that's taller than that in our blue shirts, and blue shirts must be placed in the back because it has the tallest student, then there's no way to take this photo. So again, we just return false because it's impossible to do that. So that is the entire solution. That's all we need to do. And this is actually what's called a greedy algorithm. Now, the reason this is called a greedy algorithm is because at every step or every iteration in the algorithm, we make a greedy choice. Now, this greedy choice is to pick the student that is currently the tallest. We then compare those two students together. So sorry, we're picking the students that are the tallest out of both of our different shirt colors. And then if the student that is placed in the front row, that is the next tallest, is shorter than the student that is placed in the back row that was the next tallest, then this is valid. We continue. If that's not the case, we return false because we cannot take the photo. So to quickly recap, we're going to sort both of our input arrays. Once both of these input arrays are sorted, we are going to look through them in descending order. So specifically, we're going to look at the tallest students first. We're going to try to place those tallest students. If we can place them, we continue moving on. If we cannot, then we return false. And again, before we even do any of that, we need to figure out which student is the tallest, so we know whether our red shirts are going to be in the front row or our blue shirts are going to be in the front row. So that is this entire algorithm. This algorithm is going to run in big O of n log n time. And this is going to take big O of 1 or constant space. We don't need any auxiliary space for this algorithm. We just need to do some simple comparisons where we compare the heights of the tallest students. Now, the reason this algorithm runs in big O of n log n time is because we need to sort both the red shirt's height and blue shirt's height input array. So that's going to give us technically 2 times and then n log n like that. And then after we sort both of these input arrays, we need to loop through this input array or both of these input arrays that are now in their sorted order. And then we need to attempt this placement like I was discussing. So technically that's going to give us 2 times n log n plus n. But since we know that n is less than n log n, what we can really do is we can say, all right, let's assume that n is equal to n log n, or at least this specific n right here. Let's assume it's equal to n log n. If it was equal to n log n, then what that would mean is we would change this coefficient here to be 3. So we would remove the plus n and just change this to be 3 n log n, because that's going to be greater than plus n. And then what we do is we say, okay, well, we're talking about big O notation. So since we have this constant, which is 3, we simply remove it because we don't care about constants when we're looking at the time complexity of an algorithm in big O notation. So we remove that 3, and that gives us n log n. So that's kind of a general rule of thumb. Whenever you're adding something like plus n, if your time complexity is worse than n, so you have, say, like an n log n here, or even something simple like an n squared, and then you're adding n, you can say, all right, well, if this n is smaller than whatever my larger term is, then I can simply assume it's equal to the larger term, which would give me 2 of that larger term, which is a constant, so I can remove that constant, and then that leads me to just that larger term. So that is kind of how we get that complexity here. Now, when we're talking about the constant space, the reason we have constant space is because we're going to sort both these input arrays in place. So we are not going to sort these into new arrays. So we're not going to use auxiliary space. We're just going to sort them in place. In other words, we're going to mutate the input arrays, which is fine for this problem because there is nothing that states that we are not allowed to modify the input arrays. Now, a small note here, if you were actually in a coding interview and you were given a question like this, I would recommend that you ask your interviewer if you are allowed to modify the input array. If you are not allowed to modify the input array or input arrays, then you would need to use auxiliary space. You need to use specifically big O of n space because you would need to store the sorted arrays here in a new array that represents the sorted order of the red shirt heights and the blue shirt heights. So with that said, that has been this conceptual overview. Now let's implement this solution in the code walkthrough. So I'm here in my code editor and I have my class photos function defined, which takes in 2 input parameters, the first one called red shirt heights and the second called blue shirt heights. Now the first thing that we're going to do here is sort both the red shirt heights and blue shirt heights input arrays in place. Now to do that, we'll say red shirt heights dot sort. And we're going to pass the key reverse equals true so that this is going to sort in descending order so that the first element is going to be the largest height. Next, I'm going to say blue shirt heights. I'm going to do the same thing. I'm going to say sort and then reverse equals true. Now that we have both of these sorted, we need to determine which color shirt is going to be in the front row and which is going to be in the back row. So what I'm going to say is shirt color in first row. This means the front row is going to be equal to, and then the string red, if red shirt heights at index 0, which is going to be the tallest height of the red shirts, is less than blue shirt heights at index 0, else the string blue. So what we're doing is we're comparing the tallest person or the tallest student with a red shirt against the tallest student with a blue shirt. And depending on what that result is, we're going to have red shirts be in the first row or blue shirts be in the first row. So now that we've done that, we're going to loop through all of our heights and we're going to try to make our placements like I discussed in the conceptual overview. So for IDX and then in range and then the len of our red shirt heights, what we're going to say is red shirt height is equal to, and then red shirt heights with a plural at index IDX. We're then going to say blue shirt height is equal to, and then blue shirt heights with a plural again at IDX. So we're going to be comparing the two students that have the tallest height, then the second tallest height, then the third tallest height, so on and so forth with a red and blue shirt. So now I'm going to say if the shirt color in first row is equal to the string red, so if the red shirts are in our first row, then we want to check if the red shirt that we have here, or the student with the next tallest height that has a red shirt, is greater than or equal to the next tallest student that has a blue shirt. If this is the case, if our red students or our students with red shirts are in the first row, then if any of their heights are taller than the student that we're going to place behind them, that doesn't work, or if the height is the same. So we're going to say if red shirt height is greater than or equal to blue shirt height, then we're going to return false, because this means that we cannot make this placement because there is a student with a red shirt that is taller than the next tallest student with the blue shirt. And then our red student shirts have to be in the first row, so this doesn't work. Otherwise, if that's not the case, then that means that blue shirts are in the first row. So now we want to check the opposite of this. We want to say if blue shirt height is greater than or equal to the red shirt height, then we're going to return false, because again, for the same reason as above, this doesn't work. Then finally, at the very end of our algorithm, we're going to return true. So just to quickly recap this, we're sorting both the red shirt heights, the blue shirt heights. We're doing this in reverse order so that we have it in descending order, so the tallest students first. Then we are figuring out which color shirts need to be in which row, specifically in the front or first row. We're then going to loop through all of the heights again in our descending order. We're going to grab the height of the red student or the student with the red shirt and the blue student or the student with the blue shirt. We're then going to check which color shirt is in the front row. Now, if red is in the first row, so students with red shirts are in the first row, then we want to check if the student that we're looking at right now, so the student with the next tallest height that has a red shirt, is taller than or equal to the next tallest student with a blue shirt. If that is the case, we return false because we will not be able to place these students, these two students right here. This is going to lead to a photo that is not going to follow the constraints. Now, same thing here in the opposite order when we have the blue shirts in the front row. So if we get through all of this and we don't return false, then that means that we were able to make valid placements for all of our students, which means we can indeed take the class photo, so we return true. Now, as a reminder, this solution is going to run in big O of n log n time, and it's going to take big O of 1 or constant space. So that is actually our entire algorithm. This is the solution to the problem, and that has been this video. I hope that this was helpful to you, and I look forward to seeing you in another AlgoExpert question.